Good morning, good afternoon, everyone, and thanks, Peter, for the nice introduction. My topic is design for sustainability and design for circularity for the automotive industry using state-of-the-art sustainability assessment tool, which we developed as part of the ALMA project. The presentation is outlined as follows. First, I will give you a macroeconomic view on the net zero 2050 scenario for the passenger vehicles, concepts such as design for sustainability and design for circularity, followed by introduction to the BEVSIM tool, its value proposition and capabilities, and a quick walkthrough through the simulation workflow on how the tool works, a snapshot of the alpha test results, and some additional insights with closing remarks at the end to summarize my presentation. And then we'll have some questions from the audience. In case there are some detailed questions, we can, of course, talk offline as well. Now, if you look at the net zero 2050 scenario for the passenger vehicles, McKinsey gave a forecast that there is an accelerated shift in the vehicle sales and thereby reduction in CO2 emissions from 2025 to 2030 onwards, the left side chart here. So, which is emphasized by the sharper curve of the charts, followed by for Europe and China geographies, there will be a break even for the total cost of ownership for passenger vehicles to be coming up in the time frame of 2025 onwards for two major economies, China and Europe, and this helps to go towards the net zero scenario for the industry. US will probably hit the break even at a later stage by probably 2030 or so. Now, how do we make sense of circularity? So the World Economic Forum has developed a concept through its initiative called Circular Cars Initiative, and they define the concept on circular cars as a circular car which maximizes value to society, the environment and economy, while efficiently using the resources and public goods. This conceptual definition is based on four primary principles on energy, materials, lifetime, and use rates to be optimized by maximizing the carbon efficiency and resource efficiency throughout the product lifecycle. And this initiative also emphasizes on how can we proceed forward at different levels of circularity. Currently, from a owner use and dispose concept at level 0, conceptually, the Circular Cars Initiative actually highlights on going to net positivity in the system and by 2040 onwards, thereby making a positive contribution to the society. And this entire transformation pathway is structured at 4 different levels through product decarbonization, material circularity, lifetime optimization, and utilization optimization, thereby actually enabling, as I said, carbon efficiency and resource efficiency utilization. Now, this transformation pathway, as envisioned and proposed by the World Economic Forum, covers at 4 different levels. The first one is the energy decarbonization. There are different examples which have been proposed by the Circular Cars Initiative, and at different levels, from level 1 all the way to level 5. The second pathway is the material circularity, and different concepts have been proposed here. And the third one, as I said earlier, is the lifetime optimization. And the fourth one is a utilization improvement. And all different pathways finally converge at the level 5, which is development of a mobility ecosystem, which makes a positive impact to the environment and have a net zero carbon emissions. So we are moving away from an individual car-based transport to a mobility ecosystem at level 5. That's how the World Economic Forum Car Initiative, Circular Car Initiatives actually envisions the path forward for the industry. Now, further, there is a parallel or an alternative view on measures to reduce CO2 emissions proposed by PwC, another consulting firm. And there are different options which have been presented here in this chart, right from engine concepts to alternative fuels, to reducing rolling resistance or beyond engine technology as well. Some of these approaches have been touched upon by our project ALMA, which is a Horizon 2020 program. We have touched upon weight reduction options in this project, all the way to engine concepts on moving from ICE, ignition combustion engine, to the battery electric vehicle, to the electric drive, and also incorporating concepts such as reuse, repair, and recycling to offer circular economy solutions in the product development phase. Now, what does Project ALMA aims to achieve? The goal is to design, validate, build a lightweight prototype, including the body in white, closures, and the modular platform systems. And this prototype should fall within an acceptable range of the functional, safety, and manufacturing requirements of the OEMs. The project is a collaborative effort among 9 partners, as mentioned here. CTEC and Ford are driving this program, and other partners are contributing in this overall effort. The program is a 3-year project with a total EU funding of 5.2 million euros. Now, within this project, TNO developed a tool called BEVSIM, which is a short form for Battery Electric Vehicle Sustainability Impact Model. It's a web-based tool on a Diamonds platform, which is a TNO's proprietary platform, which is built on our Shiny programming suite and has best-in-class databases on lifecycle impacts. Tool offers users to compare design alternatives. This was also talked about, that to make a significant impact on improving the sustainability performance, you have to think through on the design elements of a product. And that's why the emphasis of this tool is to allow designers and engineers to compare alternatives early in the design cycle. It's designed for non-LC experts, and you could do early sustainability evaluations and faster LCA evaluations, and also do some scenario evaluations as known experts and as known sustainability experts. The tool is customizable. You can model a full car, a subsystem, or a part for lifecycle impact assessments, lifecycle costing, or circularity analysis of your material or products. And there is, of course, possibility to include customer and user-specific data sets in this web-based tool. To make sure that there is sufficient confidentiality being maintained and version control aspects are taken care of, the tool actually takes care of through the web-based initiative where a user ID and password is provided, and separate organization-based or an individual-based login ID passwords are provided. Now, why do we need another sustainability assessment tool? Here is the value proposition for the BEVSIM tool. As I said, it allows early screening of design alternatives in the research and development phase. By offering significant savings in time and effort for performing LCA studies compared to full suite LCA software such as SIMA Pro or Gabi, it offers consistency across LCA studies for automotive applications because your entire data set is available at a single platform. It's an application and sector-specific tool with a simpler design, thereby focusing on key engineering and design elements, which at times get missed by LCA experts as well when they are moving from one sectoral LCA study to another sectoral LCA study. And it also offers lower total cost of ownership compared to full suite LCA softwares that require in-house LCA experts or services of LCA consulting companies for different organizations. Now, BEVSIM actually target different user segments. At organization level, you have automotive manufacturers, tier 1 or 2 suppliers, material manufacturers, service companies, and of course, research institutes and universities who can utilize the services of BEVSIM. And the target user segments are automotive engineers, product developers, and product designers. And of course, sustainability and LCA experts can also use this tool for doing the LCA studies themselves. Academia and LCA consultants are key element are also key users of this tool. Now, what are the capabilities of the tool? It's a single tool to do all three types of assessments: environmental through LCA, economic through life cycle costing, and circularity through circularity assessment. And it allows measurement of impacts through lightweighting, comparing of different design alternatives, or choice of materials, choice of subsystems, implications of the use phase, and the geography where your product is going to be used, be it in Europe, China, or India, and choice of different recycling options which you would like to consider at the end of the vehicle life, and various futuristic scenarios such as grid mixes for 2050 or 2030 in different geographies. Now, BEVSIM covers the entire life cycle phases of the automotive parts or the entire car, right from raw material production to processing and part production, assembly operations which are critical and many a time gets missed in LCA studies are well captured in this tool. The use phase aspect of the different cars. At present, we have the passenger vehicles captured, but we indeed plan to cover the commercial vehicles also in the BEVSIM tool. Different end-of-life scenarios going beyond traditional incineration, landfill, and recycle options to all the way capturing recycling options for plastics and composites, right from mechanical, pyrolysis, and sololysis. And an important aspect is dismantling, shredding, and end-of-life treatment options, which are also many times gets missed in traditional LCA studies, and it remains a gap as well. The last one is the awarded production aspects that are well captured. And on the right side, you see the number of life cycle inventory data sets which are available for doing LCA analysis within BEVSIM tool. Now, here is a simple snapshot of a 7-step process to do a sustainability evaluation using BEVSIM tool. First, a user is asked to select a user design of a new car or a subsystem or a part. And this could be a new user design or a design which is already existing in the database of BEVSIM. And the second step is to edit the user design to take care of any design alternatives, be it in materials or processing stages, followed by selection of the reference design. What is your market incumbent at this point in time from where you would like to improve upon? This could be a single reference design or multiple reference designs. BEVSIM gives that opportunities. The fourth step is to do a selection of the use phase method, be it for the ignition IC engine or for the battery electric vehicles. And the fifth step is selection of the right end-of-life scenarios. Which geographic area you are going to use the vehicle, what kind of recycling infrastructure which exists there, and what kind of recycling options are really possible for your products or the part, such as for steel or plastics or composites. Those options have to be selected correctly, and BEVSIM gives those guidance as well in the tool, followed by the last two steps where you're going to compare the user design with the reference designs and evaluate the sustainability impacts. Now, quickly, here is a snapshot of the steps which are available in BEVSIM. To first select and edit user design. As I said, one can also create a new user design, and there is a database of traditional or typical user designs which are available, which the user can modify based on their requirement. Now, step 3 is to select the references for the reference design. It could be one or multiple reference designs to benchmark your product. The step 4, as I explained, is selection of the right use phase method and end-of-life scenarios. BEVSIM gives that flexibility and options to consider different recycling options such as mechanical recycling, pyrolysis, and sololysis. This solution you will see is missing because from ALMA project, we figured it out. It's practically not possible to apply this solution in certain composite stages, and that's why you do not see it as an option here. And that was one of the interesting research findings of the ALMA project. Finally, you can compare the user design with reference design. Here is a sample snapshot where different mass of a subsystem are compared for a demo car with a reference car here. And you can, of course, do a sustainability impact evaluation. We offer multiple impact categories, and starting from IPCC, global warming potential, all the way to recipe midpoint. And these could be investigated from the car at the full car level, or one can go in at a subsystem level or a part level, or even to the material level to make improvements in the product design cycle. Lastly, the material circularity is evaluated by BEVSIM in step 7. Here is a sample snapshot of material circularity measured by MCI, which is Material Circularity Indicator, which was developed by Ellen MacArthur's Foundation and Granted Design. And it's on a scale of 0 to 1 to evaluate circularity performance of different material flows going into different product streams. And in this example, you would see that certain products have indeed lower circularity assessment or MCI scores, and there is a significant room for improvement on circularity performance of these materials, including plastics, polyamide, and of course for the tire materials as well. Now, how do we prove that BEVSIM is indeed ready for commercial use? We did several alpha tests, and here is an example of alpha test 1, where we successfully tested a tool using a use case built on a subsystem, which was a chassis for a BEV vehicle of a passenger car. And two independent BEV chassis models were built, one in BEVSIM and another one in a commercial software called SimaPro. And we evaluated and of course showcased that the percentage differences in the two analysis at the overall level and as well at different life cycle phases level or a material level were insignificant, less than 0.1%. Now, what are the next frontiers for the automotive emission reduction for this industry? We started with shifting from ICE engines all the way to BEV because the use phase was a big impact category or the life cycle phase, which was contributing to the overall life cycle emissions of the passenger vehicles. Now, when the BEVs are used, if you see from the left chart, the production footprint is almost equivalent to the use phase footprint because the grid mix is the current grid mix of Europe. Now, McKinsey forecast, and this is also validated by our internal analysis. I can't comment on that yet because we are in the publication phase of our manuscripts, but the analysis was quite in line with our analysis was quite in line with McKinsey's analysis, where the BEVs, when they switch from the existing grid mix to the clean grid mix, material footprint will be a dominant issue to be sorted out. Now, material emissions are now the next frontier if you have to move to the net zero scenario by 2050 or 2045. And if you look at on the right side, we will have to actually focus on certain components for design for sustainability and design for circularity solutions, which are coming in from the growing shift from the ICE to the battery electric vehicle, because the current supply chain will not remain the same because of the big reorientation which is going on in the automotive sector because the platforms have changed. And the sunset commodities should be avoided to focus on product development. Now, what is our vision as TNO for the long-term development strategy for application-specific tools? We started off with ALMA project, where we built BEVSIM tool for passenger vehicles for automotives. And we would like to actually expand this concept to offer application-specific tools which are built on common platforms for other sectors such as mass transportation, aviation, and building and infra as we go forward in time. And the emphasis is that these tools will be built on a common platform which has the same database and which are best in class databases as well. Easy to deploy and use by non-sustainability experts. The traditional users, as I said, will be product designers and engineers, and also build on robust assumptions. What we have done is we have hard-coded major assumptions as sustainability experts in BEVSIM tool, so that the non-sustainability experts are not challenged by making certain assumptions which are not relevant for their use case or for their LCA studies. Now, closing remarks. There is an accelerated shift, as I mentioned, in the vehicle sales, and especially for the battery electric vehicle, and thereby there will be accelerated reduction in CO2 emissions starting from 2025, 2030 onwards in Europe. And reaching net zero will also mean decarbonization of the EV production end of life phases, because that's the next frontier. And design for sustainability and design for circularity solutions will become critical. Lightweighting will be important, but will those lightweight products be recyclable is an important aspect because of increase in use of composite materials or multi-material solutions in the vehicle systems. BEVSIM is an application-specific tool which can be leveraged to assess the environmental, circularity, and economic impacts of passenger vehicles. And we encourage different partners, ecosystem players, and of course, sustainability experts to try out this new tool, which is offered by TNO, and which has significant capabilities and best-in-class databases to offer lower total cost of ownership for users compared to full suite LC softwares. Now, as an average user or a very specific user, can I have access to BEVSIM? I would say yes, and it also depends on your requirement. And please feel free to reach out to us to discuss your requirements, and we are always there to collaborate. Now, some complex features will be developed in the next phase of BEVSIM development. I would say stay tuned for the next update of BEVSIM tool by early 2023. Thank you very much for listening. And here is the BEVSIM development team who has actually worked quite hard over the last 2 years to make this tool a reality.